Let's have a quick recap of remainder theorem. It states that if a polynomial px and the degree of this polynomial should be greater than or equal to 1 by linear polynomial qx, then the degree of the remainder must be 0. That means it has to be a constant which can be 0. Okay, or in other words we can say suppose I have a polynomial px, degree of this polynomial is either 1 or more than 1. Okay, and suppose a is any real number. Okay, then if px is divided by x minus a, then the remainder is PA. Okay, if a polynomial px is divided by x minus a, then the remainder is PA. Okay, let's do one example of it. Suppose polynomial px is x square minus 4. Okay, now if px is divided by x minus a, suppose I take x minus 2. Suppose I divide it by x minus 2. So let's divide x square minus 4 by x minus 2. I do it over here. Okay, so it's x square minus 2x, and it is 2x minus 4. So if I divide x square minus 4 by x minus 2, I'm getting 0 as a remainder. Okay, and according to the remainder theorem, the remainder must be P2. Okay, so I calculate P2, that is 2 square minus 4, that is 0. Okay, so we have proved this through an example. Okay, so we have to be clear that if px, any polynomial, is divided by x minus a, then the remainder is PA. Okay, also let's have a quick recap of factor theorem. Factor theorem determines whether a polynomial qx is a factor of a polynomial px or not without performing the actual division. Okay, let px be a polynomial, maybe it is linear, quadratic, cubic, or any other degree. Okay, and PA is equal to 0, then x is equal to a, or x minus a is a factor of px. Conversely, we can say if x minus a is factor of px, then PA will be 0. Okay, I take one example. Suppose any polynomial px is x square minus 2x plus 1. Okay, and I find P1, that is 1 square minus 2 plus 1, which is 0. So what P1 is? It is 0. That means x minus 1 is factor of this polynomial. Okay, that means x minus 1 is factor of x square minus 2x plus 1. Okay, we'll be doing more problems in the same session. Now let's discuss some problems based on remainder theorem. In each of the following, using the remainder theorem, find the remainder when fx is divided by gx and verify the result by actual division. Friends, while solving these questions, we'll be learning two things, that is the usage of remainder theorem and the division of polynomials. Okay, division of polynomials you might have learned in your previous class, but then also for a recap, I'll be performing the actual division and will be verifying the results using remainder theorem. Okay, so first of all, we have fx as x cube plus 4x square minus 3x plus 10 and gx as x plus 4. So first of all, let's perform the actual division when fx is divided by gx. So it's x plus 4, it is x cube plus 4x square minus 3x plus 10. Now let's perform the actual division. It is x over here and I wish to get x cube. So I should multiply it by x square. Now if I write x square over here, then this x square should be multiplied with this x to get x cube. Then x square should also be multiplied by this 4. So I'll be getting 4x square. Okay. Now deduct this x cube plus 4x square from this. I'll be getting, here it is positive sign, so for subtraction I'll be putting a negative sign. Similarly over here, so x cube plus 4x square will get cancelled from minus of x cube plus 4x square. Now take 3x plus 10 minus 3x plus 10. Now how do I get minus 3x? If I multiply this x by minus 3, so it is minus 3x, and if I multiply this minus 3 to this 4, I'll be getting 12. I'm sorry, it will be minus 12. So further just change the sign both the places. Here it is 22. That means if I divide x cube plus 4x square minus 3x plus 10 by x plus 4, I am getting the remainder as 22. Now let's verify it by remainder theorem. That means if I divide this expression by x plus 4, I am getting the remainder as 22. That means if I put x is equal to minus 4, I should get the remainder as 22. Okay, so it's minus 4 cube plus 4 into minus 4 square minus 3 into minus 4 plus 10. So it's minus 64. Minus 4 square is 16 and it is plus 64, and it is minus 3 into minus 4 plus 12 and plus 10. So further I am getting 22. Okay, so that means remainder theorem is true. Okay, we can verify the results. Here it is 22 by actual division, and by remainder still we get the remainder as 22. Okay, let's do one more example. Now let's see this question. Here fx is 4x4 minus 3x cube minus 2x square plus x minus 7, and gx is x minus 1. Now let's perform the actual division. It's 4x4 minus 3x cube minus 2x square plus x minus 7. Okay, first of all we want 4x4. Here x is there, so we need to take 4x cube as the first term of quotient. Okay, so 4x cube into x is 4x4. Then 4x cube into minus 1 is minus of 4x cube. Now subtract this and change the sign. So it will get cancelled, and this is plus 4x cube and minus 3x cube. So we'll be having positive x cube. Now let's take minus 2x square over here. Now we want x cube. So x should be multiplied by x square, so we will get x cube. Now x square into x is x cube, and x square into minus 1 is minus of x square. Further let's deduct. So it's minus 2x square plus x square, will be getting minus of x square. then plus x. Further, we want minus x square. We are having x over here, so just multiply it to minus x. So it's minus x square, then minus x into minus 1 will be getting plus x. So, and we are left with minus 7. Okay, so if we divide 4x4 minus 3x cube minus 2x square plus x minus 7 by x minus 1, we get minus 7 as remainder. Okay, now this is the first step. Now we find the remainder through remainder theorem. Okay, so what we'll be doing? We'll be putting x is equal to 1. That means we'll be calculating f1. So what f1 is? 4 into 1 raised to 4 minus 3 into 1 cube minus 2 into 1 square plus 1 minus 7. So it's 4 minus 3 minus 2 plus 1 minus 7. Okay, so it's 4 minus 3 1, 1 minus 2 minus 1, minus 1 plus 1 0. Finally we are getting minus 7. So by this method also we are getting the remainder as minus 7, and from actual division we are getting the remainder as minus 7. Okay, so we have verified. Okay, let's take the next problem.